So lesson 4, part 2. So we've looked at modifying our model, declaring a DB set. We probably should have a look at this class for a minute. What is this DB set? It uses the entity framework core. It's in that part of that library. And it can be used to query and save instances of a class. So that's what we want to do. We'll use this brands object whenever we want to add, read, edit, or delete any brand objects. We can use this DB set of type brand called brands anywhere in our application for this. And we've created a couple migrations to build our brand table and then modify it each time we add a migration and then we update the database. So let's think about what tables are we going to need in order to build our store. I would say we're going to need 5 or 6 tables, probably 5 that we'll need. So what other models do we need in our store? If our store is we want to populate the catalog with drinks. Okay, yep, we'll definitely need, we need a product table. Well, Jason, in a way, the brand table is the supplier table. So we've kind of got that one already, but same idea. I just gave it the name of brand instead of supplier. So yeah, we'll need product. What else will we need? Okay, we'll need a sales. Yeah, we'll have an orders table. Connor, yep. We will need a customer or user table. Fortunately, that one we don't have to design by ourselves because we've already got one. Because we enabled authentication, right? We've got a users table with all these columns already in it. Username, email, hashed password, phone, 2-factor auth. So we can use this. So Adam, we could have employees. Probably we don't. And yeah, our employees can be stored here as well. And then we can just link users to roles. So we won't have to design our own. We will need those tables. Dan, an invoice. The invoice and sales we can use the same table. Yeah, we'll need a cart table. So as users are shopping and putting things into their cart, we can store those in the database. Yep. I could think of 2 more. So we're going to build a product model, an order model, a cart model. Something else related to the products that's going to be managed by the store owners. Okay, we could, although that could be really part of the product, right? Because we could just have a field for the inventory. What about, I'm thinking about organizing the products. What other model could we use in terms of organizing the product? Yeah, Booger, that's what I'm thinking, the category, right? So I was in the liquor store yesterday in the LCBO near me, right? The products aren't all over the place. I was looking for tequila because my girlfriend sent me a recipe for a drink we want to try making this weekend, and I needed tequila. So I wanted to look, where's the sign, where are all the tequilas? That's right, Jason, it was research, just for you guys. See the sacrifices that I make for my students? If that's not above and beyond, I don't know what it is. Okay, so we'll need a category model. And then we could do that, Adam. Yeah, we could have a sales table. I'm thinking of one thing we're going to need, though. Think about the relationship between orders and product, right? So we're going to have an order model and a product model. How are those related? If you think of a data, like in a database sense, what's the relationship like? Yeah, You're right, Adam. You're on the right track, but more specifically, what is the nature of the order and product relationship? Yeah, well, Marilla, when you say invoice, I'm thinking of the invoice and the order really as being the same thing. But think of it from a database structure, right? If we're going to have orders in the database and we're going to have products, how are they related? What? Okay, I'll be a little more specific. One order can have how many products? Many. And one, correct. Thanks, Murillo. One product can be on how many orders? Many, correct. So what's the nature of that relationship? If one order can have many products and one product can be on many orders, what's the nature of the relationship between the orders table and the products table? Thank you, Dan and Connor. It's many to many. So how do we reconcile that relationship? Because we can't have a product foreign key in the order table because one order might have 50 products. We can't have an order ID in the product table because one product can be ordered an unlimited number of times. So what do you do when you have two tables in the database with the many-to-many relationship? You would have learned this in your relational database course took last semester. How do you reconcile those many-to-many? Thank you, Dan. We need some kind of join or junction table. Right? We're going to need an intermediate table to break that many-to-many relationship into two one-to-many relationships. So we're going to put in between, I'm going to put in the chat, we're going to put in order details. So what would that order detail look like if we were going to join order and product? Okay, we'll come back to this. Let's go ahead and start building our models in Visual Studio, and then we can the models also allow us to add the relationships, and then we'll run another migration that will build these tables in our database. So let's start out simple. Let's start with the category model. So I'm going to close up a bunch of the files we've got open. So first I'm going to right-click my model folder, and I'm going to add a class. And all our model names should be singular. So we'll call this category. So now we've got a new class called category. This is going to be a pretty simple model. I would suggest we need two properties in our category model. What properties should we have? Yep, we want an ID. With get and set. Yeah, and a name, which will be a string. And remember, in .NET, our properties have to be written in Pascal case, so they can't start with lowercase.
Rich, please could you show me again how you created this category file?
Yep. So in Solution Explorer, I right-clicked my models folder and chose Add Class. And I called it Category.
Perfect, thanks.
Okay, so there's our category model, nice and simple. Now let's go ahead and build our product model. Product model is going to be a little more sophisticated. And then we want to add something to the models to indicate the relationship between product and category. So we'll go ahead, let's go ahead and make a product model now. So again, I'll right click models. We'll add a class. And this one's going to be called product. And it's going to be singular. Okay, so no S. Just move away up here. So again, we're going to want an ID. We're going to want this in all our classes. And ID. What other properties should our product model have? Okay. Adam, yes, we will. Let's put in the name for now. We'll come back to the brand. We will want the brand. Getting set. Size, yeah, there's a few ways. Yeah, for now, let's add. Trying to think. Yeah, we definitely want a price. And this is going to be a decimal. We might normally want stock for our purposes. We'll leave the stock out. Actually, you know what? We will add stock. What the heck? We may have a chance to use it. We may not. So we've got a name, we've got a price, we've got a stock. Let's also add, because we're going to want to be able to work with images later. Let's add a string so that later on we could actually upload a picture. Now we also want both a brand and a category. So the product model is actually going to have, the product table is actually going to have two foreign keys. It's going to have a brand ID and it's going to have a category ID. So first we'll have brand ID, and the naming convention is important here. It should be the model of the parent and then ID. Murilo, we could put in a description, yep, as well. Maybe just for simplicity, we'll leave it out for now. So now I also need, right, the category ID. So we've got two foreign keys. Each product gets a brand, belongs to a brand. It also belongs to a category. I know in some stores a product might appear in multiple categories. For simplicity, we'll keep this a one-to-many relationship. One category, many product, one category. Okay. So now we need to set up what are called navigation properties. We could build the table like this. And if we ran the migration, we would get these foreign keys. Yeah. And these will be navigation properties. So we don't have to use joins to connect related records. So because this model has two foreign keys, we'll say each product also has a brand property I'll put this all up on Pastebin in a minute. So these are virtual. They don't get put in the database. But we need these. This tells Visual Studio, hey, these two properties aren't just regular integer fields, these are foreign keys because we followed the naming conventions. Right? If we don't include these, then these fields just get treated like any other integer, but it won't generate them as keys. I'll put this whole class up on Pastebin. That makes it easier. Here's the link. You still needs to go inside your namespace. So this indicates the product model is the child in two different relationships. It's a child of the category product relationship. It's also a child of the brand product relationship. We also now need to modify the brand and category models to indicate that those are parent models to product. So we're going to add the same line of code in both the brand model and the category model. First, I'm going to go to brand, and I'm going to add something here. Navigation property to child. So what we're saying here is each brand has a list of child objects of type product. So we're saying brand is the parent in this relationship. And in our product model, we're saying product is the child of both this and this. So I'm going to repeat this in the category model, because the category is also a parent of the product. So I'm going to copy this property and put it in here. With these lines, with these navigation properties in our models, when we run the migration, SQL Server is going to know to create foreign key relationships between these tables. So we've created the category and the brand models. We need to create our order details, and cart models. And then we're going to run one migration that will build all of the tables and relationships for us. And then we can start using the database. So most of the work is really in designing the model classes and figuring out the relationships between the different models. Once we do that, we can just use the migrations and it will build everything inside our database. Questions so far? I realize this is all new. You probably haven't done this before. This is a different way of building your app. Okay, just checking, that's good. So let's go and let's do our order model. And then we'll do order details, and then we'll do cart. And notice all my models, so they're all here. Here's brand, category, product. They're all singular. So I'm going to add a new class called order. Singular with a capital O. Again, we'll have an ID as usual. What other properties do we need in our order table? Now, Jason, remember the relationship between order and product, right? What happens if someone goes into the store and they buy 10 different products? Right? Remember, we've got a many-to-many relationship, so we can't add the product directly in here. We're going to use a junction table for that. We do want a total. I agree, Adam. So that'll be a decimal. Yes, we want to know who the customer is. So we're going to use this table that we've already got, this ASP.NET users table. And it doesn't use integers for IDs. It actually uses a 450 character max string. So we'll use a string as the customer ID. What else do we need in the order table? Well, Booger, again, the quantity is related to the product, right? What if I buy 10 bottles of wine, 1 bottle of tequila, right? So the product quantity, we'll store it, but not here. Yes, definitely, Chris, we want the order date. So we want a date, time, order date. So we've got an order number, or many of you mentioned invoice, so that's kind of the same thing. How much was the total? Who bought it? What was the order date? Remember, people are buying online. So what other information are we going to need? This is an online store. So what other information? Yeah, Chris, we will do online payment later, but we don't want to store the payment info because that creates a whole bunch of liability. We're going to let that get stored in a payment gateway, which we're going to use later in the term. Because there's a whole bunch of compliance rules if we're storing payments in our own database. Yeah, so let's add an address. Let's add an address, city, province, and postal code. I'll put this up on Pastebin. So we get a unique order number. How much was the total? Who bought it? When? Where's it going? Okay, so there's our order class. Again, we'll need to modify this in a minute with some navigation properties, but these are the basics of what we need. We probably also want the first name and last name. I should put that in here as well. So we can look up orders by customer name. So I'll add those two. Not necessarily Adam. This table doesn't actually have first and last name field, so we'll maybe ask for it when they check out. So I'll put this up on Pastebin if you want to grab it. So now we can make the order detail class, and then we'll have to figure out the relationships. So we've got two more models to make. This is most of the heavy lifting. Once we're done creating the models, everything's going to get really easy. But designing the models properly is kind of at the heart of this. So now I'm going to make an order detail model. So again, I'll add a class in the models folder, two more. I'll call it order detail. Again, no S on the end. Our model should be singular. As usual, we'll start off with an ID. Now remember, this is our junction between order and product, which is many to many. So let's think of this scenario, right? I go onto the store and I want to order multiple products. Each product I buy would be a new order detail record. So what are the properties we need in this model? Okay, so first thing, yeah, so that's going to be our foreign key number one, right? We need two foreign keys because this is a junction. That's right, Sviatoslav and Adam. So here are our F foreign keys, right? So we're going to have a public int product ID. So what product am I buying? And also, what order is this product purchased on? Is it my bottle of tequila or is it Jason's bottle of tequila? Right? We can both buy the same product, but I'll have my own order ID. Jason will have a different one. Okay, what other columns do we need? Rugra, you mentioned one of the other columns. You suggested it for the order table, but it needs to go here. So we know which order and which product. Right, we need the quantity, right? How many bottles of tequila? Whoops. And I think there's one more thing we should track. Right, we need to know the price because remember the price can change, right? Maybe I bought something on sale. So if I go and look up the order later, I can't find today's price. I need to know what price it was purchased at. So Good suggestion, Marilla. Right, so we need a decimal. So we can record the price of the product at the time it was purchased. Maybe the user has a discount coupon, so one customer is getting it for a cheaper price than other customers, for example. So now we need the two navigation properties here to connect the order detail to our two parent models, right? To both the product model, because one product can appear on many order details, and to the order model, because one order can also have many order details. So now we'll have a public product of product. So every order detail has a parent product. It also has a parent order. So now a customer can go in, they can purchase multiple items, and all of those products will be tied to the same order. And if they buy 5 different products, they're going to have 5 order detail records, all with one order ID. So I'll save that. And now we're going to need to go to both the product model well, not on a single order detail. So Adam, if a customer bought 3 different products, they get one order ID here, right? Let's say I got order ID 400. And if I bought 3 different things, I would have 3 records in the order detail table, each one with order ID 400, but with a different product ID each time.
So this order detail is just for any given product the person is choosing to purchase.
Right. Okay. Here, let's do it visually for just a second, okay? So let's say I've got 100 just tequila, 200. Okay, so these are the products in the store. I make a new order and I get order 2000. Okay, so here's my order number. What do I buy on my order? So I buy 2 bottles of tequila, 1 bottle of vodka, and 1 bottle of rum. So each one of these, still all of them have order ID 2000, but each one has the different product ID that I purchase. Right, I'm sorry, 2 bottles of tequila. So my quantity is 2. Okay, but the order ID for all of these is 2000 in each case. Does that help? So we've linked our order detail model to the parents. We now have to do the same thing in the parents that we did in the brand and category parents. We now need the navigation properties to the order detail. So here's the full order detail class. I'll put it on paste bin. So you're going to do a mini version of this in your assignment, but you only need 2 tables. And there can just be a one-to-many relationship. So the child table will have this foreign key field and 1 navigation property to the parent. So now we need to go to our parent, our product. So we're going to create a list of type order details, called order details plural. And so this is our child ref. So the product model is a child in these two relationships, and it's a parent in this one. I'm then going to copy the child reference and put it in the order model as well, because order is also a parent to order details. So I'm going to copy that. And add in this child reference. We need one more table, which is the shopping cart table. As users are putting things in their carts, we want to store those in the database. And then if they check out and pay, we'll basically copy each record in their cart to a new order detail. What product did they buy? What order is it attached to? How many do they want? And what's the current price? So we'll go ahead and make our cart model. So I'll add one more class called cart. I'll also push all my changes up to GitHub in a moment when we're done this, in case you missed anything in the models. So again, we need an ID as usual. What other fields do we need as someone is shopping if we want to store what they're adding to their cart? What other fields would need to go in here? Yeah, so we need the quantity. We need the product ID. So again, a foreign key. So we'll have an int for quantity. Okay, do we have an order? When does the order ID get generated? Does it get generated as someone's shopping, or does it get generated at a different part in the process? When you're buying something online, yeah, right. So until a payment is successful, until you commit to checking out and you put in a payment, you won't get the order ID yet. So we need some other way. How else do we distinguish? So if Adam and I are both shopping and we both put the exact same items in our cart, how do we know whose cart is whose? Right, so based on who the user is. So again, I'll use customer ID as a string. And then also maybe we'll again track the price. So how much did the item cost at the time I put it in my cart? I think this is everything. Connor, we could store it, but we can pretty much calculate. We will show that on the shopping cart page, but we can pretty much calculate that on the fly. I mean, it's not wrong if you want to store it, but keep in mind this is for every product, and there may be multiple products on one user's cart. So I think we'll just calculate the total on the fly because it's a single value for all the cart items. And now we need the navigation properties. Well, this is the price of each product in the cart. Because remember, again, we may have multiple items, each at a different price. So yeah, we could calculate the total. Yes, that's right, Adam. So if I have 3 items in my cart, I'll have 3 records attached to my customer ID. So parent, nav, property. So every cart item has a product. Oops. Oops. So there's the product model, parent, and now again we'll have to go back to the product model and add the child reference to cart. So there's our cart class. Put it up on paste bin. So now again, I need to go back to the product model. We've already listed 2 parent references and 1 child. So these will now be child refs. So we're going to have a list of type cart because one product can appear in many different shopping carts. Jason, it's a good question. I'm not going to make the reference simply because the classes for the users, because we're not working with our own user table, we don't need a model to work with these tables. So I'm not going to make that reference. No, because those are special auto-generated tables for user authentication and role authorization. So if we look, I think I put it up here. If you refresh your week 4 folder, here's basically our database schema that I laid out. Oh, and we may want a date in the cart as well, so we know how long has something been sitting in the shopping cart. But basically what we did, this is basically our schema. So I'll add a date created to the cart model as well. Not critical, but probably useful to have. So we've only got one more step, and then we can, I'll put this code up on GitHub in a minute, then we can generate our database. So I've got to go back to this application DB context file that we worked with earlier that's in the data folder. So we've added our brand DB set. We now need to declare all 5 of our additional models as public DB sets. So I'll say declare all the models so the DB can work with them. So I'm going to declare a DB set of each one of these So we've got categories. We have a DB set of type product. And then we've got order, order detail, and cart. So our last one is called carts. So I've added these 5 declarations underneath the declaration we already had on line 13. I just threw them in the chat. I'll save that. Now I'm going to take out my password from the connection string, and then I'm going to push all this to GitHub. So if you've missed anything, you can grab anything you need from GitHub. Pause for. Okay, so it should have pushed everything to Git. Yep, so it just updated. So if you need to reference, all the files are here in the models. And under data and application DB context, it's now got my model declarations. So we're going to do one more thing, then we're going to take a break, which is I now want to create a new migration and update the database, which should build the remaining 5 tables as well as create the relationships between them. So I'm going to go back to my package manager console and type add-migration, create store tables. So I'm just putting in a description of what this migration does. We're creating the store tables. I'll hit enter. So it's going to generate a pretty long migration script. Okay, I'm just going to values, not worried about that. I'll just ignore that. Warning. And then I'll type in update-database. So this should run the migration. And when it finishes, if I go back to Management Studio, we should see new tables here. So if I refresh my list, we now have all of the tables. And for example, if I expand the products, it shows me, for example, all the keys. So we've got our primary key, as well as we've got foreign keys from the brand ID and the category ID. The order details has got 2 foreign keys as well. So those foreign keys are generated from these navigation properties. This is how it knows, Entity Framework knows what relationships to generate in SQL Server. So I didn't have to build the tables manually here. I could just build the classes and model the relationships in Visual Studio. And the database migrations then give us the database structure that we need. So now we're ready to start interacting with the database and creating, editing, viewing, and deleting data. Everything's all set up for us to do this now. So the real work is in planning out the models. Planning out the models, normally we would do this, I would recommend doing it this way, visually first, identify the entities, list the properties, and then figure out the relationships between them. So it is 12:53. I would like to take a break here. We do want to do some more when we come back because our app is now ready to interact with the database. And there's some other neat tools. We've done the hard stuff. So we're going to use some of those tools so we can do create, read, update, and delete. And then I'm going to show you how to publish the web application to the internet using GitHub and Azure. So we will come back at 1:05 and we will tackle those things. Okay, so all the code we've done so far to date, it's in the GitHub repository if you need it. Okay, we will be back at 1:05.